This is on the entropy and the entropy change. The entropy function S introduced in the second law of thermodynamics is explained below. Entropy function S represents the ratio of heat involved Q to the temperature T of the process. That is, S is equal to Q divided by T. This relation is valid only for reversible process. If a system is changed from state 1 to state 2 at a very constant temperature, and if delta Q reverse is the heat produced or involved in the process, then the entropy change of the process delta S is given by S2 minus S1, which is equal to delta Q reverse divided by T. So here the process is a reversible process. So from 1 to 2, it can be 2 to 1 once again. Entropy and the change in entropy of the process delta S are each state functions, even though Q and delta Q path functions. In a reversible process, entropy of universe remains a constant. S universe is equal to S of system plus S of surroundings, which is equal to constant. So entropy change delta S can be derived for various thermodynamic processes. The first one is isothermal process, which is delta S is equal to 1 by T integration of 1 to 2 from state 1 to state 2. So delta Q reverse, which is given by Q2 minus Q1 divided by T. So this one is capital delta S and this one is small delta Q. This is small delta. Isothermal and isobaric process. Here the temperature is constant and the pressure is constant. Isobaric, which indicates that delta S is equal to 1 by T 1 to 2 delta Q P comma reverse. Isothermal and isochloric process. Here the temperature and the volume V both are constant. In that case, delta S is equal to 1 by T 1 state 1 to state 2 delta Q V reverse. The term natural process means the process is spontaneous and does not need to be induced. In order to find out whether a process is spontaneous or not, the entropy change of the system and the surroundings for the stipulated process is considered. If this change is positive, if the entropy of the universe increases, the process will take spontaneously and irreversible. If the entropy change of the universe is 0 or negative, the system will behave as non-spontaneous process. When the external pressure is less than the internal pressure of the gaseous system, the gas expands spontaneously. When volume increases in expansion, the disorder in the movement of gaseous model or molecules is increases. Thus, spontaneous processes are associated with increase in disorder. When disorder in a process is favored, it occurs spontaneously, and we say that the entropy change is positive. Entropy is a measure of a microscopic disorder in the system and also represents spontaneity. For a reversible process, a delta S system, which is equal to minus delta S surroundings. You are able to see a typical example of Troughton's rule. The bubbles cannot form since the vapor pressure is less than the atmospheric pressure. Bubbles are forming since the vapor pressure can overcome the atmospheric pressure. So let me go back here. The delta S of universe which is equal to delta S of the system plus delta S of the surroundings is equal to 0. For an irreversible process, spontaneous delta S of universe is greater than 0, that's positive value. Entropy change in a physical transformation can be determined particularly for evaporation of liquids at the boiling point using a typical rule that's called as a Troughton's rule. According to Troughton's rule, the heat of evaporization, delta H vapor, in calories per mole divided by the boiling point of the liquid in Kelvin is a constant and is equal to 21 calorie per degree per mole. This is called as entropy of vaporization. So delta H vapor is equal to enthalpy change of vaporization, which is equivalent to the latent heat of vaporization. This equation is useful for estimating the molar heat of vaporization of a liquid of known boiling point. So substances that deviate from this rule are these things. We are going to see it on the entropy and entropy change. The low boiling liquids such as hydrogen and helium, which boil only a little above 0 Kelvin. Polar substances like water, alcohol, which form hydrogen bonded liquids and exhibit very high boiling point as well as very high delta H vapor. Liquids such as acetic acid, whose molecules are partially dissociated in the vapor phase and possesses very low entropy vaporization, which is very much less than 21 cals per mole per degree. Those liquids that obey Troughton's rule are said to have behave ideally. Characteristics of entropy is the term entropy is evolved for the formulation of second law of thermodynamics as a thermodynamic state function. Entropy change delta S of a system under a process is defined as the constant equal to the ratio of the heat change accompanying a process at constant temperature to the temperature of the system undergoing the process. So the process should be reversible at that temperature. Here is the formulation: delta S reverse is equal to delta Q reverse divided by T, which is in Kelvin. So Q is not a state function, but for a reversible process, delta Q is equal to Q2 minus Q1 divided by the temperature T of the process, which is a state function. So a spontaneous process, this is the third point I am going to discuss. A spontaneous process is accompanied by increase in the disorder R, randomness of the molecules constituting the system. Entropy increase in all spontaneous process. Hence, entropy may be regarded as a measure of disorder or randomness of the molecules of the system. Here is the fourth point. When a system undergoes a physical or a chemical process, there occurs a change in the entropy of the system and also in its surroundings. This total change in the entropy of the system and its surrounding is termed as the entropy change of the universe brought about by the process. For an isothermal process, the temperature is constant. The entropy change of the universe during a reversible process becomes 0. So the entropy of the universe increases in an irreversible process. The energy of the universe remains constant, although the entropy of the universe tends to a maximum. For a spontaneous process at constant T, delta S is greater than 0 and it is positive. If delta S is positive for an equilibrium process, delta S becomes 0. For a non-spontaneous process, delta S is negative. So for spontaneous, delta S is positive, equilibrium delta S is 0, and non-spontaneous delta S is negative. The next point which we are going to discuss is units of entropy. The dimension of the entropy are energy in terms of heat into temperature, which is in inverse. So entropy is expressed as calories per degree, which is referred to as the entropy units. Since entropy also depends on the quantity of the substance, the units of entropy is calories per mole, per degree per mole, or EU. So per mole. So CGS units of entropy is calorie per Kelvin, which is denoted as EU. The SI unit is joule per Kelvin and denoted by EU. So 1 EU, small EU, is equal to 4.184 capital EU. Let's move on to think about the isothermal process. Entropy change is related to the enthalpy change as follows. For a reversible and isothermal process, delta S is equal to delta Q reverse divided by T, where delta H is the heat absorbed or evolved in the process at a constant temperature T and a pressure P. So delta S is calculated from delta H as delta S is equal to delta H divided by T, where T is the temperature of the process involving delta H and the amount of change at constant temperature and pressure.